Swayam Prabha. Digital India. Educated India.
Hi friends, welcome to this week's module, which is a case study. And in this week, we are going to talk about how to develop an emotional virtual personal assistant as part of this case study. So basically, so far we have learned a lot about the theoretical aspects of affective computing. Now the idea of this week's lecture was to bridge the gap between the theory and the practice for you. So here we will try to understand how can we apply that we have already learned in the previous weeks to develop an application, to develop a device which is emotionally intelligent and can be used in real life. I will try to provide as much codes as well, and hopefully we will get to play with it in your own time. So here is the outline for this week's module. First, I will be talking about, of course, the motivation behind the development of such an emotionally intelligent virtual assistant. What could be some of the challenges? I will be talking about the methods and the techniques using which such an assistant can be developed. And I'll be talking about the ethical concerns around such a system when it is deployed in real life. And I'm glad to inform you that we also have managed to do an interaction with Dr. Aniket, who is a faculty in Purdue University, and his most of the work is related to the affective computing and emotionally intelligent machines. And we will be talking with him at the last of this lecture to understand how has he been investigating in this area and how he has been developing some of the real world applications by making use of his research in his lab at Purdue. Okay, so with that, let us get started. So first thing that we want to understand is what exactly is a virtual assistant. Now when we talk about a virtual assistant, basically virtual assistant is something that we all have seen. It's just like Alexa, Siri, Cortana, etc. And the idea of virtual assistant is that it takes an input or it interacts with the humans and it takes as an input their voice, and it could be started with a some wake word such as hey Siri, hey Google, and then of course since speech is the modality that we are taking it as an input, so please pay attention that speech becomes the mode of the communication. Then the next thing happens is the automatic speech recognition. Of course, the assistant tries to understand what is that the user wants to communicate or wants to understand. And this is where, when we're talking about the automatic speech recognition, this is where we also will try to understand the emotional context of the entire interaction between the agent and the humans. Once we have understood the intent and the emotions that are there in the speech, we will try to, of course, apply the NLP and try to understand how can we respond to this particular request that the user has made. And then there is, of course, dialogue management system, which helps to create this interaction between the user and the agent. And then once the agent is ready with the response, then the agent converts the whatever response that it has in the text format to a speech format and send it back to the user. So as simple as that, you may ask, for example, hey Siri, how is the weather today? And Siri would respond that okay, the weather is sunny and warm, for example, right? And this is where we want to insert the emotional intelligence component into it. So what we are talking about here is trying to develop an Alexa, Siri or Cortana kind of assistant, but which is also emotionally intelligent. So I hope that it's exciting and fascinating enough for you. But if not, then let us try to look at that what could be some of the use cases of such an emotionally intelligent virtual assistant. So for example, this kind of assistant can be used in mental health and the therapy, where this kind of assistant can be used to help people with mental health disorders or, for example, emotional struggles. This kind of agent, it can recognize the user's emotional state and it can provide guidance, and it can support with the coping strategies and emotional support in the real time. And on the top of it, this kind of an agent, it can track the user's emotional state over a period of time, and it can provide insights to the therapists and to other healthcare providers, or let's say to their nearby stakeholders, to their nearby relatives and friends. So that is one interesting application. Other application that could be is the customer service, in providing the customer service and the support. So in this case, such an agent can be used in to provide a more personalized and empathetic experience to the customers. And the idea is here that such an agent, while doing an interaction with the customer, will be able to recognize users' emotions, and it will be able to tailor its responses accordingly to provide, let's say, more positive and satisfactory responses to the user. And we all have seen how the customer service agents interact with us, and definitely it's a very tiring job. Hats off to the customer care agents, but of course we can always do better in this area. One other domain that it can be really interesting to have this kind of an agent is the education. So in the education domain, such an agent can be used to help students learn more effectively. So the idea is very simple, that if you have such an agent, it can try to identify when, for example, a student is struggling and needs more support or needs additional support, and hence it can help provide targeted feedback and support to them to overcome whatever obstacles they are facing in learning a particular topic or concept. Other, for example, very important category could be the entertainment. So basically this kind of an agent can be used in entertainment to create more engaging and interactive experiences, which can be really of a lot of demand. So for example, imagine that you have a video game which is using this kind of virtual assistant. It can adapt to the player's emotional state and maybe provide a more immersive and adaptive environment for the user to enjoy. So this can be a very interesting application. Other interesting application that, frankly speaking, I and all my colleagues in the academia would definitely appreciate a lot is having a virtual assistant that can be used in the workplace to help employees manage their stress, improve communication, and increase productivity. So it is very common for the workplace, for the individuals who are working in a particular workplace, to get overwhelmed from time to time with the anxiety and stress and the lots of tasks that are their hand. So the idea is that can this kind of system provide understand when the employee is feeling, for example, overwhelmed or frustrated, and maybe it can provide support and additional resources to help them become more effective and overall have a positive experience while conducting their job. So that is one. And of course, these are only few pointers that I'm mentioning, but of course there could be many more applications. And to the answer to what else, I would let you think about it, that what are the other domains where you would like to use such an emotionally intelligent virtual assistant. So imagine that if you have a Alexa or a Siri or a Cortana which is also emotionally intelligent, what can you do with it? So the creativity is the only limit here. So I hope that you have been feeling motivated enough to have such a system and to develop such a system and to go through the case study of it. Now, of course, such a system is not going to be easy to develop. So let me make your hopes not so high. But of course, we will see what could be some of the challenges. And by no means this is an exhaustive list. I'm just trying to provide some pointers here. Of course, the very first challenge that is there is the accuracy. So what we want of course such a system to be as accurate as possible, but it can be really difficult because there is a lot of variability in the emotional expressions as across individuals, cultures, and the contexts. And I hope you can see that the type of the modality that we are talking about here is the speech modality. So you may want to recall the concepts that you have learned during the emotions in speech lecture by my colleague Dr. Abhinav. So the idea is that okay, here there is a lot of variability, and this variability can be due to many different factors, which was discussed in that particular lecture. So for example, it could be due to the speech patterns, due to the accents and different dialects, right? And as simple as that. For example, when you are making a speech, there is a even bigger challenge apart from the dialect and accents and everything is how can such a system detect sarcasm or irony in a speech when it is communicating with the humans. We humans are very good at making sarcastic comments, and of course we use it very efficiently in our day-to-day communications. So if we were to use such a communication with an emotionally intelligent agent, how can such an agent detect that kind of thing? And of course, these are can be, the agent has to look into the tone, also has to understand the context and so many other things. So nevertheless, accuracy remains a big challenge for this. Of course, other big challenge of such a system that we can envision is the operational requirements in real time. It has to be able to perform in real time. Because if not real time, then we will not be able to provide a seamless user experience, right? And of course, what it requires the processing and the response time should be very, very efficient. And of course, it has to be supported with a high performance hardware and the software. So this comes as a trade-off between what we want to invest and what we want to gain out of it. But nevertheless, the idea is that we should not be able to make the compromise with the user experience. Otherwise, the users will not interact with it and it will lose its purpose. Okay, so third point is the multilingual support. I think this is even more applicable to a country like us, like India, where we already have 20 plus official languages, and unless and until we are able to cater to the needs of all the languages, we will not be able to reach to the big portion of the individuals in the domain. One other interesting challenge is, of course, of the bias and the discrimination. And it turns out that, like any other technology, this particular technology or the virtual assistant that we are going to develop, it may also reflect the biases of the individuals like us, and also like the data sets who create and train the models, and it can potentially lead to the unfair treatment of certain groups. And these biases that we are talking about, and hence resulting discrimination, can be due to several factors. It can be, for example, due to data bias. So for example, the data that has been recorded, imagine if we are recording a data that is only making use of individuals or the participants from northern part of India, then of course we may not be able to cater to the exact requirements of the users from the southern part of India, for example. Other thing could be is the gender bias. What is gender bias? Imagine that we are having a data where all the participants or majority of the participants, they are belonging to one particular gender, say male, and then there are very few females in the category. Then of course the model may have a very hard time in trying to understand the emotions from other gender or other genders in this case. Similarly, of course, we can have a culture bias as well, which we already talked about in the last thing. Culture bias is basically, it turns out that there are certain regions of certain regions where people may have a higher tone in comparison to the other regions. And similarly, there could be other cultural differences. So taking into, unless and until we are able to understand the entire demography of the participants, which are our target users, we will not be able to completely get rid of the bias that may be present in such a system that we are trying to develop. And last but not the least, of course, there is a privacy concern can be a big concern when it comes to the development of such virtual assistant. And the idea is, of course, we should not be able to collect the data without the user's knowledge or their consent. And of course, even if we are collecting the data, we need to have a very robust data encryption protocol. We need to have a secure storage of such a data and all the transmission protocols, and we need to have compliance with the privacy regulations, not only at the national but also at the international levels, such as GDPR and the HIPAA regulations that we have now. So this is a very, very important requirement, and these are some of the interesting challenges that can be there while developing such a system. And of course, as I said, these are by no means an exhaustive list. So there could be many other challenges, and I invite you to please brainstorm about it. What do you think could be more challenges when it comes to the development and the usage and the deployment of such a emotionally intelligent virtual assistant. Okay, so now having understood that what exactly we are talking about a development of an emotionally intelligent virtual assistant. In short, it's Alexa or Siri plus having emotional intelligence. We already saw that can we have lots of use cases in the education, entertainment, mental health, workplace productivity, so on and so forth. And then we also looked at lots of challenges. So having looked at all those things, now we can try to formulate some of the requirements that it may have. Please note that the exact requirements may vary from one to another, and it will depend on the business use case that you are trying to have, and which may come from the managers, or which may come from the business stakeholders also. So of course, the very first requirement, that whatever system we are developing, it should be able to recognize emotions in speech, as simple as that. And let us say that for the sake of the simplicity, taking as a toy example, it should be able to distinguish at least the basic emotions of happy, sad, angry and neutral. So we are just talking about the basic emotions, and rather than talking about like the entire spectrum of the emotions, to keep our life easier. Of course, we have already gone through the emotions in speech, so we are going to rely on that understanding a lot. If you have not gone through that, or if you do not recall some of the concepts, then I will invite you to please go through that and revise emotions in speech, and then maybe come back to this part later. Of course, this is the first requirement. Of course, second requirement is it should be able to take the data as an input in a voice format. So we do not expect the user to type like a chatbot, but we expect the user to say something using a speech modality. So it should be able to recognize the emotions in the speech. It should be able to take which underlying hypothesis. It should be able to use the speech as an input. Of course, while doing so, the idea is it not only should be able to understand the emotions, but also it should be able to understand user's intents, and it should be able to generate appropriate responses. So for example, maybe the user is asking something, and it should be able to understand what is the user asking, and there may be certain emotions attached to it. So both, so intent plus emotions. And as of now, most of the time the virtual assistants that we see, Alexa, Siri, Cortana and all that, they are able to understand the intents, but maybe they do not have a lot of understanding of the emotions or emotional intelligence, right? And of course, it should be able to generate appropriate responses, taking into account both the intent plus emotions. Okay, that's the difference between the agent that we are trying to develop and the agent that has been developed in the past. And of course, we already established that unless and until it's working in a real-time environment or in a near real-time with a near real-time efficiency, it will not be able to serve the need of the user. And having raised the concern of the privacy, of course, we already understand now that we should be able to protect the user data. Primarily, we are talking about the speech data, and of course, we may have access to certain demographic information, such as the user's identification information and location and all that. So we should be able to protect user data, speech and the personal information. As I said, by no means all this is an exhaustive list, and for example, we can keep on adding the requirements to it. And one nice requirement to have would be, so I would say that these the top 5, these are something that we can term it as a essential requirement, because without having it, we may not be able to launch even to a particular city or even a particular region. And this is something that we can call it as good to have kind of thing. But of course, if we do not have this multilingual support, we may not be able to cater to the multiple users to a users at scale. But nevertheless, having top 5 is a good start for us. And of course, as I said, the exact specifications of such an agent may depend on the business use cases, and I will invite you to brainstorm about it, that what could be the business use case that you are targeting and what additional requirements could be there for such a business use case. Perfect. So having understood now that what exactly we want to develop, so we want to develop an emotionally intelligent virtual personal assistant, just like Alexa, Cortana, Siri, but with an emotional intelligence. I will keep repeating it again and again so that you understand it very thoroughly. Now let us try to dig in a bit more technical aspect of it, that how exactly can we develop such an agent. And I think we know already the answer to it, but of course here we will try to put different pieces together and hopefully it will make some sense. So here is a very skeleton code that I have tried to prepare, which gives rough idea about what are the different steps that we are going to follow to develop such an agent. Okay, of course, imagine this skeleton agent code has been developed in Python. I will provide you the code files as well, just so that you can play with it. So for example, this is of course you are going to have to import some libraries such as speech recognition, a simple library, which, and then of course you are going to initialize the speech recognition and the language identification objects, create some initial objects and do some initialization. You are going to initialize the virtual personal assistants. Depending upon, you may be using a particular set of hardware and the software, so you want to initialize them, and then this is where you are going to keep track of the user's personal preferences and users for example history over a period of time and things like that, and that is where we are going to just call it as a context. So basically you would like to keep a track of the user's context, and hence you may have a context object as well, and you want to keep updating that. Then of course then we are going to, this is something that is going to run in a infinite loop, continuous loop, and basically so that is why we have a while true loop. Of course while true, then we are going to have we will keep listening to the user's input, and once we listen to the user's input, we are going to get an audio of it. Once we have the audio of it, then of course depending upon what are the functionalities that we have, maybe one of the first thing that we may want to do, we may want to identify what is the language in which the user is speaking. Having identified the language, maybe of course the next step would be to understand what is the emotion that is there in this particular speech data. We may want to understand, convert this thing in the text format to be able to do some more processing over it. We may want to, having identified the emotions, we also want to identify the intent. For example, if the user is asking something, saying something, commenting something, things like that, and so you may want to understand the intent of the user as well. And then of course then taking into account, please pay attention to this point, taking into account the intent, the emotion and the context. So the context could be the user's preferences, user's history over time, how the user has been interacting with the system. Maybe the system is able to understand what sort of preferences the user is developing while having the interaction with the agent. So this is the context. So basically now the appropriate response is going to be developed with the help of the intent, emotion and context. These are the three things that are really important for such an emotionally intelligent virtual agent. And after that, of course, once we have a response text, we can simply convert the text to a speech, because we want to communicate back to the user in the form of a speech. And once we have this response audio, we can simply play the response audio in a speaker, and then that is how the user is going to understand to it. And of course then accordingly, if we have certain update in the user's context, we can do that update in the context, and then this can go on in a while loop. Roughly speaking, this is the skeleton of our emotionally intelligent virtual assistant. As you can see, this is really simple, but of course this captures the gist of the entire system. I will invite you to please go through the skeleton code that will be provided to you with this week's lecture module. Perfect. So we have understood the top level idea. Now let us try to see how an end-to-end life cycle of this system will look like. So this turns out that the end-to-end life cycle of a system is not going to be very different from a typical machine learning or deep learning systems, where for example we have two major components of it. One is the machine learning aspect of it, and one is the operational aspect of it, where we have the deployment and all that. So we will talk about all these aspects in bit detail, but basically when we talk about the machine learning aspect of it, what it means, of course we need to have some data. We are going to play with the data, do some pre-processing, feature selection, extraction, all those kind of things, and then after playing, we are going to create a machine learning model which is going to in this case going to help us understand the intent, the emotions and maybe the context also to a certain extent. Of course, then we are going to do the registry of such a model, and then we deploy in real system. And once we have done the deployment, then maybe of course we will have to keep monitor the usage and the working and the functioning of such a system, and as and when required we may want to retrain the system, and having retrained we may create another version of the model, and then that is how the operational deployment it goes on. So basically this is the roughly the end-to-end life cycle of our virtual assistant will look like. One aspect that we are not focusing a lot here is the hardware aspect, is because it is understood that of course along with this software we may want to give it a shape of a hardware, a tangible interface, which could be in the form of like for example a Google speaker, or for example any device which is sitting on your table. But nevertheless there is going to be a hardware plus software component. Here we are focusing more on the software, but you can easily integrate the hardware development part into it as well. Perfect. So now we have understood the end-to-end life cycle. So the very first step is the preparation of the data, and this is, I would say, this is the second step. I would say this is the third step. This we can call it as the fourth step. This is the fifth step, and of course this is the sixth and the seventh step as required. So let us talk about the very first step, which is the data or the preparation of the data. So okay, before I discuss it, what do you think, what could be the type of the data that we will need? So our idea is that we want an agent which is able to recognize the emotions in the speech. If you recall your concept and understanding from the emotions in speech module, then of course what we need a data set of audio recordings and hopefully corresponding emotion labels. And there are some data sets which are existing, and for example we have talked about the EmoDB and RavDes data sets. So maybe we can make use of either of these data sets. Apart from this, there is this IIT KGB data sets also that was discussed in the class, and you may want to use that data set as well, because for example EmoDB and RavDes, for example, they do not cater to the Indian population because they have been recorded mostly using Western participants. Nevertheless, for the sake of the simplicity, let us assume that we take one data set. It's the EmoDB dataset. What exactly this EmoDB dataset or these datasets that we are going to use will have or need to have? Of course, they need to have the text data and the speech data that is labeled with the emotion categories. And such as, for example, what we are talking about is, imagine that we have an audio signal which is saying, I am so happy to be here. There is an audio, there is a corresponding text, and then of course there is an emotion level associated with it, which is happy. Similarly, we have another audio signal, I am feeling really sad today. There is an audio, there is a corresponding text, and there is an emotion level to it, which is sad. Similarly, for example, we have another audio signal, I am so angry with you right now. Audio, corresponding text, audio, corresponding text, and then there is this emotion level angry. And then just for the sake of completeness, there is another type of audio signal which could be, for example, I don't really care one way or the other. It's something like, a neutral tone. So you have a speech data which says I don't really care one way or the other. Then you have a text data corresponding to it, and then you have an emotion level attached to it, which is the neutral level. So this is sort of data set that we are going to have. Of course, the exact choice of the data will depend on so many different ways. Maybe you may want to curate your own data set as well, but nevertheless, curating your own data set, so far I hope that you understand, it can be a significant time consuming process, and it will require significant resources. Depending upon your need and the requirements, you may want to use the existing data sets. Just for the sake of this case study and example, we are saying that okay, let us just go ahead with the using the EmoDB dataset, and hence what we would like to do, we would like to of course load this data and maybe process it to a certain extent. So this is a simple skeleton code. Again, as I said, I will be providing you the code. So basically, essentially what we are doing in this particular thing, that of course we are importing certain libraries. You may be already familiar with some of them. NumPy, Pandas, all are basic pre-processing libraries, and Librosa OS, basically to connect to OS, for example, the operating system libraries, and so on. So the idea is, of course, we are going to have a path to the data set. Maybe it is going to be in your drive, online drive, or maybe it is going to be in your system. And then, of course, there is the labels. We already agreed about it, that we are going to have only 4 emotions: happy, sad, angry, neutral. For now, we can, of course, since we are talking about the speech data, there is going to be some sampling frequency to it. We are going to limit the sampling frequency, let's say, to the 16 kilohertz. Then we are going to have a function to pre-process the audio files that we are going to capture. So basically, what type of pre-processing we can do? We can basically, simply do the resampling of the data from whatever target frequency, whatever frequency it had, to the maybe original target frequency. So which could be, so for example 16,000. We can normalize the file. So basically, if you remember the normalization, the idea is, if the data is coming from different users, we may want to normalize it so that we should be able to make a fair comparison across different users. So you may want to normalize it. So that is how you are going to have a normalized or pre-processed version of the audio file. That is the function to pre-process the audio files. Next, we are going to have another function which is going to load the EmoDB dataset. We assume that we are using the EmoDB dataset. You can replace it with any other dataset of your choice. Of course, we are going to have, like all the audio files folder, we are going to have the emotion path. And for all the audio file in the audio files, simply we are going to get the Y, that is the sample of it. And then we are going to get the corresponding label. So the audio file and the corresponding label. So basically Y and the label. And then, of course, we can simply append to the data that we have, and we can create a matrix kind of a structure for it. And this is the final data that we have already loaded from the dataset that was available in a particular folder, in a drive, or on our operating system. Okay, so now when we call the main function, what is happening? Basically, the very first thing, we are going to load the EmoDB dataset. Once we have done the loading of the EmoDB dataset, we are going to shuffle the dataset. So if you recall, shuffling the dataset is basically done to avoid any sorts of bias that can be there, and we simply shuffle it and have a good mix of the data that is available to us. Next, of course, we are going to split the dataset into the training and the validation sets, or training and the testing, for the sake of the simplicity. So for example, in this case, we decided to use 80% of the data for the training, and the remaining 20% will go for the validation or the testing set of the data. Okay, just to make our life easier, we are going to convert the entire data set into a pandas data frame, so that to have better manipulation control over the data. And simply we converted the entire thing into a data frame, which we call the train DF, and the testing data frame, we call it as the validation DF. So this is just a skeleton code. Of course, you may want to tweak it here and there in order to suit your needs, right? Perfect. So now this caters to our first part of the life cycle, which is the preparation of the data. Next, we want to explore the data. When we say that we want to explore the data, what it means, that we may want to understand, what sort of feature selection and feature extraction can be done. We are, for now, for the sake of the simplicity, we are restricting to a very simple machine learning pipeline, rather than going into the deep learning pipeline. More or less, the steps are going to be the same. So it turns out, if you recall your emotion in the speech lecture, then there are lots of relevant features for the emotion recognition. We may want to use, for example, some of them, which is the MFCC coefficients. We can look at prosody features such as pitch loudness, speech rate. We can look at some of the spectral features, spectral centroid, spectral flux, etc. We can look at some of the time domain features. Now, what exactly these features represent, you may want to refer to the emotion in speech class to have a better understanding of it. The idea is that we may want to extract certain features which are going to be relevant for the recognition of the speech emotion in the speech data. Okay, so let us say that we just identified a list of relevant features. Then, of course, once we have certain features which could be huge in number, then what we want to do, we may want to perform the feature selection to reduce the dimensionality of the entire features and to optimize the performance. And there are lots of ways in which we can reduce the dimensionality of the feature space. And for example, there is PCA, LDA, mutual information based feature selection methods. There are many, and then recursive feature elimination. But okay, so we may want to use one or the other depending upon your specific requirements. The discussion of all these techniques is beyond the scope of the class, but of course I will request for the interested users to look at these techniques and understand what could be the pros and the cons of one technique over the other when we want to do the feature selection. For the sake of the simplicity, we are just going to use, let's say, PCA for the feature selection and the reduction of the dimensionality. Of course, it is important to have an balanced number of features that we are going to use in accordance with the model that we are going to choose, because it turns out that if you have very small number of features and if you have chosen a very complex model, the entire thing is going to result in an overfitting. We want to avoid that. Of course, the basics of it can be understood in any common machine learning or a deep learning course. So to summarize, we have already identified the data. Now we are trying to identify what are some of the features that we can use and what is the feature selection technique that can be used to reduce the dimensionality of it. So as I said, we are going to use these many features. For the sake of the simplicity, we are going to use PCA. So let us try to see a skeleton code which is going to help us do what we want to do for the feature exploration. So of course, this is some initial libraries that we are going to this, and then these are some of the parameters that we have to define in order to initialize and certain components related to the different features and the feature selection technique, that is the PCA that we have chosen. So of course, the exact understanding can be taken by going in detail about a particular feature or the particular technique. So once we have done that, then let us try to define different functions that can extract the different features for us. Of course, one simple feature is the MFCC feature, as we agreed. So we define an extract MFCC function for that. Other function is to extract the prosody features from an audio signal, which is going to be the pitch magnitude, again some other features, and then we are going to have another function to extract spectral features from an audio signal. This is again some spectral features that we have already defined. We can calculate from the given same audio input, and then we can have some time domain features from the given audio signal. So please pay attention that these are the skeleton code. So you may want to tweak it or you may want to add more details to it in order to make it executable. I will be providing you all these codes for your understanding. Okay, so once we have defined how to do the feature extraction, how to do the feature selection, how to do the feature extraction here, next we can simply do the feature extraction and the selection in a main file, let's say. So we can simply load a particular audio file. We can extract the MFCC. We extracted the prosody features using the earlier defined functions. Similarly, the spectral features. Similarly, the time domain features. We simply concatenated all the features into a feature matrix, and we can simply apply the PCA on the top of it, and then this features PCA is going to represent the reduced dimensionality of the entire features that we have selected. And how many components? Since we have defined 20 components, so this is going to reduce the dimensionality to the 20 principal components of the PCA module. Perfect. So I hope that now the second step is also a bit clear. So to summarize, what we are trying to do is, we have done the prepared data. We have already explored the features that are there. Next, we may want to dive a bit into the model. So let us try to look into the model now. So basically for the model, now there are we are trying to club two steps, model and the registry. We'll talk a bit more about it. So basically when it comes to the model, of course we are talking about a machine learning or a deep learning model. The very first thing we have to do is we have to define the machine learning model architecture. It could be as simple as that. So for example, maybe if you want to define the type of the model first, for example, you may want to make use of neural networks, then of course you will have to define how many layers and like how many neurons and what would be the input layer, what would be the output layer look like, and so on and so forth. So that is how you define first the machine learning model architecture. You are going to of course look at what could be the loss function, optimizer and the metrics for the evaluation for a particular problem. Of course, accuracy can be one particular metric, that is simply to have F1 score could be another metric. So you can, of course, make use of one or the other metric depending upon the specific requirements. Then of course, you are going to do the training of the model on the training set that we have split before. We are going to evaluate the model's performance on using the evaluate function on the validation set, so that it does not hamper it does not affect the models and introduce any bias in the model performance. Okay, and then of course, depending upon what the response we are getting, we can tweak the model architecture. For example, reduce the number of layers, increase the number of layers, reduce the number of neurons, increase the number of neurons, so on and so forth. Of course, we may want to also tweak the hyperparameters. For example, what could be the learning rate? Can we reduce the learning rate? Can we increase the learning rate? So on and so forth. And of course, dataset itself, maybe you want to use the entire dataset, you may want to use another dataset, you may want to use multiple datasets. So all these are the questions that you will have to answer while tweaking the performance of the model. And then at the end, you will have to retweak this 4 and 5 again and again and again until you arrive to a satisfactory performance. Of course, what can we say a satisfactory performance? So for example, if we are talking about a 4-class classification problem here for our emotionally intelligent virtual agent, a random chance of doing the classification or a random chance of identifying the emotion that is there in the audio is 25%, right? 4 classes, 25% chance. So we would like to have, at least 75% to begin with. And then of course, ideally we want to have as high performance as we can without having a lot of variance in the performance. So of course, these are certain, you will have to look into the model architecture to understand how can it be achieved. Once we have done the training and the validation of the entire thing, then we may have a separate testing set where we can get this is important, an unbiased estimate of the model's performance. So then this is what we are going to report to the external stakeholders. Once we have model training and testing done, we may want to save the trained model. And when we say we want to save the trained model, means model and its parameters, of course using some save function, we will see in a bit. And it turns out that whatever model that we are saving, we have to register those models with some model registry. So basically, without going into too much detail, the model registration is what? We want to register the model and its metadata along with its performance into some repository so that we can have a better version control over it. And this is something that is an essential step sort of, before doing the deployment of the model. And this is something this model registry allows you to track the different versions of the model, and of course, if required, replace one version over the another depending upon how it is performing in the real deployment. So let us see let us see a skeleton code which is going to do this 8 steps for us in short. Okay, so just for the sake of the simplicity, let us say that we defined a neural network model architecture with some layers and with some this ReLU functions as an activation softmax. Exact details, of course, you can look into the architecture of the neural network. Once we have defined it, then we are going to compile the model by defining what is going to be the loss function, what is going to be the optimizer, and what will be my metrics for the accuracy. Of course, the next is going to be, you will be training the model on the training data set. These are certain parameters that are required for doing the training of the model, and then you are also passing the validation data on which you want to tweak the hyperparameters of the model. You are going to look at the validation evaluation of the model on the validation set. You may obtain certain accuracy. Once you have obtained the certain accuracy, of course, this is the repetition of steps 4 and the 5 as we said before until we are achieving a certain satisfactory performance. Once it is achieved, then of course the next thing is finally you are going to report the test accuracy on the test set, And then, so okay, like just to make it clear, you may want to split your data into 3 different sets: training, testing, and the validation. And usually, for example, a simple thumb of rule is 70, 20, 10. So basically, you have 70% data for the training, 20% data for the testing, 10% data for the validation, and or you may want to interchange one thing over the other, right? So that is how you create 3 different sets from one given data. Okay, so now and this is basically you do all to get an unbiased estimate, and the details of it can be understood by taking any machine learning course. So once we have created a particular model, so basically this is what we are saying, that our model is now ready here. So you may want to save the model to a certain path. So basically like this is where you are going to dump the model. We are actually saving the model with like in pickle format. And once you have dumped the model, then maybe you want to register the model with a model registry. You may use any model registry. So for example, this is your model registry URI. There is going to be some metadata that is associated with it, such as what is the model version, what is the accuracy of the model that you just obtained, and then these are certain other parameters that you require to do the registry of the model onto on some registry data. Right? Okay, so then roughly this is what the skeleton code will look like for our emotional intelligent virtual assistant. So, and now let us quickly go back. So now where we are, we already completed the prepared data, we already explored the features. So we already sort of clubbed the model building and the registry. Now we want to look into a bit in the deployment, and of course the monitoring can go further. Okay, so model and registration is done for us. Okay, deployment. So of course, when we are talking about the final deployment, it can be done, on a particular hardware. Maybe like of course you can keep it in a laptop itself. You may want to keep it in a mobile phone itself, or you may want to create a dedicated tangible device, for example, which you can place on your table or on the user's table. So assuming that like you decide for a particular hardware, which could be, for example, as simple as that Raspberry Pi, you have to understand and take into account that it should have sufficient processing power. We are talking about running some machine learning models on it, and it should have sufficient memory, of course, and storage, RAM and the storage to run the model that we are trying to create. Nevertheless, whatever model we are creating, having identified a particular architecture, we may want to convert the entire model into a light format, which can be optimized and made compatible with the chosen hardware. So for example, in this case, we can simply make use of the TensorFlow Lite framework to make it compatible with the Raspberry Pi and TensorFlow that we have been using to develop the machine learning model. So having chosen the TensorFlow Lite framework, next what we want to do, we want to optimize the entire model by converting it into a TensorFlow Lite format, and maybe we may have to quantize it to reduce its size and computational requirements, depending upon whether, for example, it is fitting to the hardware, whether it is giving a real-time performance, and so on and so forth. So these are really tricky steps, and you will have to fine-tune it depending upon certain things. Then of course, once you have done this thing, once you have converted into a TensorFlow Lite format, you want to load that optimized model onto a Raspberry Pi, and then you want to interface it with its Raspberry's microphone and of course speaker. Fortunately, Raspberry Pi has both the microphone and the speaker, so it can work as roughly as a good hardware for you. So of course, having loaded it onto the Raspberry Pi, next we may want to deploy the model on the Raspberry Pi, and then we want to test it by running different audio inputs, and we want to understand whether, for example, the output that it is giving, whether it is the output that we wanted to have, or comparing it with the ground truth in the real environment. So just a rough idea about how the deployment will look like. Of course, please pay attention that we have been focusing solely now on the on the emotions only. More or less a similar kind of software development cycle can be followed for the intent, which I am not talking about because this is something that Alexa, Siri, Cortana has already been doing. And other thing that we have not talked about specifically is the context. So context is something that also has been integrated to certain with certain efficiency in these existing virtual models. But so we have not been talking about the intent and the context, but more or less the idea is that the way we are going to understand the emotions, we are going to understand the intent and the context, and we will be referring to the bigger block there. While generating an appropriate response, we will be looking at the emotions, the intent and the context altogether. Roughly, I wanted to give you a brief of how an end-to-end deployment will look like. So just a skeleton code for this real-time life deployment. Again, I am saying that this is just a skeleton code. So basically, of course, you may want to check the Raspberry Pi that you are, for example, or any hardware that you are using for its power, memory and storage. And once you have this thing, so you may want to optimize the model by using TensorFlow Lite. So just simply load the model. After loading the model, you will simply convert the model. You are going to save the optimized model with some other name, and then of course then you are going to load this model onto the Raspberry Pi with some interpreter, and then of course the next is you may want to now run and test it on the new data that is coming, right? Having model trained already on an existing data. So you may want to define a pre-processing audio. So basically pre-process audio's function you can use from the previous that we already looked at a skeleton code. How can we pre-process the audio? Normalization, resampling and all those things, actions. We have a function for that. We can define another function, to make predictions using the loaded model for a new data. Of course, simply we can, we can collect the audio, we can do some pre-processing as required, and basically this is where, we are going to load the model, the optimized model, and we are going to run the inference on the optimized model. We are going to get the output in a tensor format, and then we are going to convert into some readable format or some interpretable format, and this is the output of the predict emotion function will look like. Once we have the emotion output, similarly we have this predict emotion, we can have the similar way, we can something like we can have another function such as identify underscore intent, for example, which we already had, for example. Similarly, we can have something like identify or add something like context to it. These kind of things we can have also. All together, these three will come together, these three functions will come together, and then what we can do, we can have a prediction of the emotions. Similarly, we can have a prediction of the identification of the intent, identification of the context, and then accordingly, rather than just returning the predicted emotion, maybe we want to generate the appropriate response as we saw in the very first skeleton code, and then that is what we are going to return, and that is how we are going to simply finally test the model in the real time, right? So that is roughly and in a very simplistic way the deployment of a model on a particular hardware such as Raspberry Pi. I will be providing you these codes. Hopefully you will be able to go through these codes. These are just 2 examples, just the skeleton codes. Please feel free to tweak it as you wish and feel free to play with it, and hopefully I will be very happy to see if you are able to integrate all these pieces together and come up with a real and nice working emotionally intelligent virtual assistant for yourself maybe. Okay. So with that, then let us move to the next module.